So I want to write some code that's going to open any one of these FYI emails, extract each individual item one by one, and then within an item, pull out the subject, when it occurs, uh, if there's a website, what the website is, and where it is. In order to do that, we're going to have to do some string processing, a little bit more than we've done so far. What I want to do is start by extracting each individual item. And notice the items go from a bunch of, they're separated by dashes, right? A sequence of dashes. So conceptually what we could do is read in line by line, and then when we see a bunch of dashes, we'll know we're at the beginning of a new, FYI item, and we keep on reading line by line, build that up until we get to the next set of dashes, and then we'll know we have completed one item, and we can start looking for the next one. And as we have one item, then we can go and send it off to a function that we can write to process it. So how do we write this code? Well, we've already just got a few lines of code here to read the file, but instead of just having this hang out, let's put this in a nice little utility into a function. Maybe we'll call it process file, and we'll pass in a argument which is the file name. And this way it'll work for any file name, and we can try it on each of the different FYI files rather than having to do it, write code once for each one of these. So we'll go ahead and write this function. Now this will work right for any file name, and we can try calling it with a particular one, fyi1.txt. All right, this ought to do the same thing we've already gotten. Yes, it does. So now, instead of printing the line, let's think about how we can implement the logic I just was describing about looking for a dash line, building up some text until we get another dash line, and then stopping. As I say it, you can kind of realize that in order to do this, we have to have some kind of memory. We have to know whether we have seen a dash line or not. Because if we haven't seen a dash line, well, that means we're at the beginning of the FYI file, right? And we're going to ignore the whole beginning. If I go to the top of this file, there's just this kind of introductory stuff which I'm going to skip, right? It's only when I get to here that I even should care about it. So I have to do some kind of code before I get to the dash lines and a different kind of code when I'm in the middle of a dash line. So you can imagine maybe I have just a variable that says whether or not I've seen a dashed line or not. So whether this processing of items has started, and then I can start building up the text. It's a little hard to sort of envision how this whole thing's going to work just building it up in your head. And it's often easier, as we've seen before, to write a little diagram to sort of show how the sort of logic works. And I'm going to introduce something called a state transition diagram to help us do that.
So let's represent our FYI data generally as a bunch of input text followed by one of those dash lines, followed by an item, which is a bunch of lines of text, followed by a dash line, another item, dash line, and so on. So what we want to do is, by processing this text line at a time, generate a single string which represents this item, and then another string which represents this one, and another one that represents this one, and so on. So how do we do that? Well, the first thing we have to do is recognize that while we're processing lines before we hit the first dash line, we're in this special state that's sort of like an initial state. So we're going to represent this using what's called a state transition diagram. And it's simply a circle that represents where we currently are, and then you'll see when we get a certain kind of input we can transition into other circles. This we'll call our initial state. So basically, we start off in the initial state, and maybe we'll represent that by saying start. Then, as we process each line, what we're going to say is that for each line, if it's not one of these special dash lines, then we stay in the initial state. So maybe I'll just say not equal to dashes. So in other words, in our initial state, if our input is not equal to dashes, then we stay in the initial state. If, on the other hand, we did get one of those dash lines, then we're going to go into our processing state. So maybe we'll call this our item state. And when we do this, we can create a new empty item. And again, every time we get some input which is not equal to a dash line, then what we want to do is we're going to stay in the item state, but we're going to add to the current item. On the other hand, if we do see a dash line, we're going to stay in the item state, but now what we're going to do is process the existing item and we're going to reset the item. And we keep on going, and that's it. This is a very simple algorithm. We only have two states. We have our initial state, and depending on what input we get, we either stay in the initial state or move to the item state. We stay in the item state for the rest of the time, but depending on what input we get, we can do something different. That's the essence of a state transition diagram. It shows us visually, depending on what our inputs are, what state we're in, and then what we can do depending on what state. This algorithm only has two states. Later on, we'll eventually see, hopefully, more complex state transition diagrams.